Hello, everybody. I hope you're all enjoying your internships as much as I am. So, as I mentioned last time on the introduction, I'm conducting my internship over at my host organization, Something Fishy, which provides professional aquariums for their clients. So, this internship has been quite interesting, working with all different types of professional aquariums, freshwater, saltwater. My areas of focus have been on the water quality management, coral propagation, and fish health, and maintaining fish health and quarantining fish when they're sick, so that way we can stop the spread of disease. So I'm gaining hands-on experience in aquatic systems, I'm learning disease identification, and I'm applying my fisheries science knowledge and concepts into controlled environments, which are aquatic ecosystems, right? Contained small ecosystems. So we're looking at these small aquariums or these big aquariums, some of them, at as managed ecosystems, right? So the stocking density, how many fish are in there, the fragmentation of the corals, recruitment rates, diseases that outbreak lead to mortality events, and then water chemistry is basically going to be what determines the habitat quality, right? Is it on the stable? Is it on the rise? Is it declining? So the day-to-day activities and projects that have taken place in are a lot of those things I just mentioned, but also some weekly team meetings, um, logging some of these metrics, right? So we can go back and look at them. And then also just, excuse me, just routine maintenance across systems, right? So things need to be kept clean. One of the major achievements that I've been able to accomplish with the help of one of my mentors is the captive rearing of freshwater angelfish, right? So essentially, we have a tank inside the facility that's about 150 gallons. It's a freshwater tank. It's a display tank out in the lobby, and it has a ton of angelfish in it. And the angelfish obviously laid eggs. So there was a successful fertilization and egg laying, and then that led to us facilitating the successful hatching. So my mentor, one of them, noticed that the angelfish laid eggs on a particular leaf in the tank, and so that tree was a real live tree right inside the tank. So we are able to cut that leaf off and take that and transport it to a separate tank and quarantine it so it would not be preyed upon or destroyed. So that led to the successful hatching and the larval development. So now they're in the early juvenile stage. This was a video here, a very short video. It's not allowing me to play it, but essentially what you just see is them swimming around, right? So we were able to take this makeshift tank, I guess you could say. It's just really a plastic canister. We drilled some holes in the bottom, outfitted it with a lid and PVC, um, rigged up an air tube so it wouldn't be so overpowering that they would, you know, get damaged or hurt, or drown, die. I mean, it sounds silly to say, but the normal air stone would essentially drown them out. So this is a tubing, a piece of like IV tubing going up with a filter wrapped around a piece of PVC with a couple holes in it. So it's just got a bloop, bloop, bloop at the top. So that way it's not anything overpowering. So the fish are just swimming around in there. Little tadpoles, I guess you could call them, hatchlings. So we're currently monitoring these hatch success and the survivorship rates, and this could be compared to successful recruitment event in the wild, I guess you could say, right? But it's obviously a captive, you know, rearing event. But so far, this is a huge milestone for myself to see this take place. So this shows successful husbandry, right? And that's what this whole internship is about for me. It's about learning the practices of husbandry and aquaculture. So that's a major achievement for myself. Coral propagation has been something that's been a whole learning curve for me. So what they call fragmentation of coral colonies, is essentially just taking a pair of bone scissors or a blade and cutting a piece of coral off and attaching it to a plug. And so what happens is actually the smaller the piece of coral that you take off, the larger the percentages of it surviving and growing into a recruit. So, like we talked about with recruitment, right? Successful recruitment, it's funny because they're actually called recruits. But when you frag off a piece, as they say, and you take off a small piece and glue it to a small plug, you allow it to grow a little bit, and then you take it off that plug, glue it to a piece of live rock or next to another piece of its same species, it tends to grow. Doesn't have to be the same species, but the species that it gets along with, right? It tends to grow very quickly. So something I found out in my literature review upon research, and then also brought it into my internship, shared it with others, and then they found the research interesting, but they proved it from trial and error to be true, that it's supported by the evidence. The smaller the piece of the fragment, the faster it grows because essentially it forces the coral into a heightened state of rehabilitation, I guess you could call it, and it starts to heal quicker. So they use these things called dips as well to make sure that corals are prevented from disease outbreaks. They're basically iodine based, and it's essentially just you can think of it as a bath. You just take the piece of coral fragment out, sit it in a bath of iodine. Um, a dip, they call it an iodine dip bath. It's a mixture of mostly iodine and other things, and then take it out and put it back into its tank. So you do that every so often, so that way you can wash things off, I guess you could call it, right? And allow it to absorb, kill off some of that bad bacteria on top of it. Oops, sorry. So, fish health, disease management, been another big thing for me. I've been extremely interested in diseases for a long time, especially with my projects in salmon. Like I was talking about in the intro, my projects with salmon, looking at wild fish mixing with um, stockfish, and then mixing with also, diseases from fish that are in aquaculture for food consumption, not wild, but mixing because they're close in area in the ocean, in these contained farms. So that's always been a very big, interesting thing to me, very big passion of mine, and interesting factor of why I took these courses. So this was a really cool experience to start to see diseases of all different kinds and all different places. So this little guy over here has something they call Popeye, which is actually this thing called exophthalmia, which is a bacterial infection that causes fluid behind the eye and just essentially forces it out of its socket. And then you have all different types of other diseases, and identifying them in a fish can be quite hard, to be honest with you, because it's all about the visual acuity of your eye. You got to look for things such as discoloration, spots, yeah, all different things like that. So some of these are the main ones. You can see some of them bacterial, some parasites, some fungal, uh, but they're all different medications and medicines that could be used to treat these things, which is also quite interesting to me. I did last week, I actually set up a bath, again, you could call it, but it was a tank of fish, or just about three or four of them, same species of fish, that had a disease that were being dosed with this Canaplex, which is just a white powder substance that you just measure it out by the scoopful, and based off of how many gallons, put it in the tank, let it sit. You got to come back in a day, dose it again, come back after that, and then do a change of water so that way you can kind of dilute it and then go from there and see and have to repeat. So there's all these different medications that and treatments, right? So some of them are like this copper-based treatment when fish come in, and the question of that, have they been, prone or susceptible to some diseases they might have been during shipment, or um, you know, from the facility where they came from, right? Not necessarily during shipment, but from the facility that they came from, they might have been exposed to disease, and then during shipment exposed to stress, right? So when they come in these copper-based treatments, they could actually place them in a tank with um, exactly that, right? It's a copper-based treatment that dilutes through the water and kind of kills off these bad bacteria that build up and lead to these diseases. So when a fish has a disease, it goes into what's called the quarantine protocol. So it ends up in this hospital room, and it gets a little under observation tag, and has to get checked and medicated. So some of the obstacles, right, are occasional fish mortality due to disease, coral bleaching during or after fragging, right, because they're stressed, they might not grow. managing large numbers of fragments. As you can see here, there's tons of tanks with tons of frags, and then maintaining the stability across all these different systems, right? So it's not just here in house, but it's also what are we bringing out to the client and how are we going to manage it for them, right? We don't want disease outbreaks out in their showroom, stuff like that. So some outcomes, connections, general application of my scientific learning, right? So I've been applying a lot of the questions I've built up over these last four classes and a lot of just the kind of takeaways, I guess you could say, and trying to apply them and look at, okay, is this, it might be a aquarium, like I said, it might be a fish tank, but is this something that, happens here too? So identifying diseases, right? Coral biology, like I said, has been something that's been very interesting to me. And then the whole husbandry aspect, right? That's something that I have been kind of learning about and talking about and reading about for a long time, but not getting my hands on, right? So for a while, taking these courses, thinking about what prospective jobs I'd be looking at after graduation, something that's always interested me besides just environmental management, Department of Environmental Management or Conservation, is not just, I wouldn't call it aquaculture, but I'd just simply label it as hatchery management. I've always been interested in how we, supply the stock of fish for catch and release or catch and keep um, only. It's a huge thing in all of our in all of the states across this country. We all have stocking programs. All departments of environmental management have stocking programs, um, and so it's just always been something that's interested in me and something that I could end up seeing myself work in. So this experience has definitely deepened not only those interests but my practices, right? It's allowed me to really put this into play and learn a little bit more about how does husbandry actually take place. And so in the coming weeks, I'm going to continue to monitor those angelfish for their survivorship, continue the coral propagation, growth tracking, and continue the management of diseases. All right. So this internship so far has exceeded my expectations a lot. And like still in awe and shock that it was right down the road. It's in Warwick, so it's not far from campus. And I happened to find this just through, going to a career fair and reaching out. And so it all just kind of fell into place. I'm really, really pleased and really happy with what's going on. And I'm learning a lot. So thank you all. I hope you guys are enjoying your internship as much as I am. And I will catch you guys on the other side.